Okay, here is trigonometric differentiation. So answer the following questions on trigonometric differentiation. Show clear and logical work on the space provided. So 1 reads y equals sine x times cosine x. So that means y prime is going to be cosine x times cosine x plus negative sine x. Negative sine x times sine x, right? That is cosine squared x minus sine squared x. Number 2 is y equals sine of ln x plus 3x squared. So y prime equals cosine ln x plus 3x squared. And then 1 over x plus 6x would be our answer. Let's just leave it like this. Okay, and then number 3 is y equals cosine squared and tangent x inside. So this is basically cosine tangent x to the power of 2. This whole thing to the power of 2. So y prime is equal to 2 cosine tangent x times the chain rule, I guess. So inside function is cosine tangent x. So negative sine tangent x, and then the inside, which is tangent x, so derivative of that would be secant squared x. So we got negative 2, let's see, negative 2 sine tangent x cosine tangent x, and then just secant squared x. So that's our answer. 4 is y equals cosecant x times tangent x. So y prime would basically be negative cosecant x cotangent x, right, times tangent x plus secant squared x times cosecant x, right? Okay. So cotangent x is basically tangent x over 1, right? 1 over tangent x, right? So that means that this will cancel out to be negative cosecant x plus secant squared x times cosecant x. Let's see if we can simplify this any further. So secant x would basically be cosine squared x over 1 times sine x over 1. So that does not simplify for anything, so we're just gonna leave it like this. If you want, we can try to factor this out, so we can say negative cosecant x be 1 and then minus secant squared, which does not lead to anything as well. Yeah, I think it's basically this, because the trigonometric identity that we know would be 1 plus tangent squared x equals secant squared x, right? And then that is not in the form of our trigonometric identity, so we'll just leave it like that. And then we'll just leave it like that. And then y equals secant of cosecant x squared. So x squared is inside the function of cosecant x, so we can say y prime equals secant cosecant x squared, and then tangent cosecant x squared, and then the inside function, which is cosecant x squared, we can try to take the derivative of that, which would be negative cosecant x squared cotangent x squared, and then take the derivative of the inside of that, which is x squared, so that is 2x, right? So we can say that our answer is negative 2x. Now let's see if we can simplify any of these. So secant is cosecant x squared over 1 times sine. Okay, so we can't simplify that. Okay, and then we can't simplify much right now. We have sine x squared over 1 times sine. So there's nothing we can simplify any further. So just leave this one like this. So we can say negative 2x, and then just this will be our answer. And then number 6 is y equals 1 over x plus 6 tangent squared. So y prime basically would be, y equals is x to negative 1, right? So, okay, so negative 1, x negative 2, plus 12 tangent x, and then secant squared x, right? Okay, so that's that, right? And then if you don't like the negative exponent, we can change it to negative x squared plus 1 plus 12 tangent x secant squared x. And then, yeah, okay. Yeah, we can't simplify this any further, right? So we'll just leave it like this. Number 7, y equals 1 plus secant squared x over sine x2. Okay, so y prime would basically be, derivative of 1 plus secant squared x. So 2 secant x, and then secant x tangent x, right? Okay, and then that times sine x squared minus derivative of sine x squared would basically be 2x cosine x, right? And then cosine x squared, and then 1 plus secant squared x all over sine squared x squared. Okay, so this one I would say is pretty complex. You don't really have to simplify this, so I'm just gonna leave it like this. Again, most teachers accept all algebraically equivalent forms, so if you just leave it like this on any of your exams, I think you should be fine. But again, check with your teacher. Yeah. And then let's see. Number 8. Y equals 3x squared plus x cosine x, so y prime is equal to 6x, right? Plus, and then this we need to use product rule for, so cosine x plus negative sine x times x, right? So that means 6x plus cosine x minus x sine x. That would be our answer for number 8. Number 9, we have y equals x squared plus cosecant x all over tangent x. So y prime would mean 2x plus cosecant x derivative would basically be negative cosecant x cotangent x, right? And then multiply that by tangent x right here, and then minus secant squared x times x squared plus cosecant x all over tangent squared x. Okay, and then let's just check if we did that right. Okay. Yeah, that's what we did for this one. Again, it's a little bit complicated, so I'm just not going to go into the simplification. If you actually want to see a simplification of this, I can try, but you just don't have to. I'm just going to show this just in case you need to see how to simplify. Okay, so 2x tangent x. First, I think you need to distribute everything. So negative cosecant x times cotangent x and times tangent x. So since these two are reciprocals, you can just cancel that out and say that we have negative cosecant x, right? Yep, and then minus secant squared x. And then we'll see if we can try to simplify these two. So cosine x squared over 1, and then sine x. So we can't really simplify this. So I think this is the furthest we can try to simplify. Yeah. So minus secant squared x cosecant x all over tangent squared x. Yep. So this is it. The next one is y equals secant x ln x. So it's a product rule question. So y prime equals secant x derivative, which is secant x tangent x, and then multiplied by ln x, plus derivative of ln x is 1 over x times secant x, right? So we got the answer. We can try to factor this out. So secant x, and then tangent x, ln x, plus 1 over x. So this would be the answer. Okay. And then number 11, y equals e to the sine x times square root of cosine x. So y prime would equal to cosine x e to the sine x, and then also cosine to the power of 1/2, right? And then plus 1/2 cosine x to the power of 1/2, right? Because cosine x to the power of 1/2 is equal to this, right? So, and then we do negative sine x because of chain rule, and then e to the sine x for product rule. Okay, so for this one, we can combine our like terms, which is cosine x. So cosine x to the power of 3 over 2 times e to the sine x, and then plus negative 1/2, plus 1/2 cosine x to the power of negative 1/2. And since we have a negative sine x, we can just change the positive sign to the negative sign, and then sine x e to the sine x. Okay, so we can use the e to the sine x to factor it out. So e to the sine x times cosine x to the power of, let's do negative 1/2, and then that means our remaining one would be cosine squared x, right? Because cosine x to the power of 2 over 4, when it's combined with negative 1/2, would lead to 3 over 2, right? Okay, so we're going to do cosine squared x inside the parentheses to represent this part, and then we also have negative 1/2, and then sine x as our answer. Okay, so this would be our answer right here. And then number 12, it's asking for y equals tangent root of x over x, square root of x, yeah. Okay, so for this one, we can try to make it a product rule thing, because I feel like quotient rule is a little bit more complicated. Yeah, so we can do quotient rule. I would say if you are able to change it to quotient rule without making things too complicated, or change things to product rule without making things too complicated, then definitely do product rule. Because product rule, you don't have a denominator that you need to think about. You don't have to make it too complicated. Like squaring your denominator is like a lot of work. Not a lot of work, but it kind of doesn't look too simple. So always maybe resort to product rule if you can. So this one would be y equals x to the negative 1/2 times tangent root x, right? So y prime would be negative 1/2 x to the negative 3 over 2 times tangent of square root of x, and then plus secant squared of x square rooted times the chain rule. So x to the 1/2 derivative would be 1/2 x negative 1/2, right? So 1/2 x negative 1/2, x to negative 1/2, and then times x to negative 1/2. Okay, so for that means that we have negative 1/2. Actually, before we do that, we can just try to factor it out a little bit. Negative 1/2 x I know I said I would factor this out, but before that I think I realized that we need to simplify something. So secant squared root x times 1/2 and then x, so add these together so you get x to the negative one power, right? So that's that, and then let's just try to factor things out, which would be negative 1/2 x to the negative 3/2 power tangent root x, and then negative x to the 1/2 power, right? This is right, and then secant squared root x would be our answer. So negative 1/2, okay, and then tangent x minus root x. This would be our answer.